So when I do these problems, I usually try and organize it by its bases. The first thing I do is I go and I say, well, what base do I have? In part B, I only have one base. I have A. So I put down my base, and because this is multiplication, I know I'm going to be adding the exponents. So I write down my two exponents, I add them together, I get A to the fifth. That's it. This is the answer. I'm done. Now notice in part C, it's a little more complicated for a couple of reasons. Reason number one is we have two numbers here that aren't bases. They don't have exponents. They're just numbers floating around. Keep in mind, all this is multiplication. So when I go to organize my problem, I'm just going to put them out front. I have a -2 and a -8 that are being multiplied with everything else. And then I say, okay, well, here's my actual base. I have m's. So let me put my m. And then I just need to add their exponents together. Keep in mind that if a variable or a number doesn't have an exponent, its exponent is 1. So this is really m to the 1. And to that, I'm going to add 5 because that's the exponent on the other m. So going through, -2 times -8 is +16. And then m, we have 1 plus 5 is 6. And this is my answer. The only time I want you to multiply the numbers is when they're like this. They're different and they don't have exponents. We'll come back to that in just a minute, what I mean by that. The quotient of powers is the other property that we went over. And this one, again, it's all about shortcuts. So there's two different ways that we can kind of approach this problem. We can expand it out and cancel things out, or we can use the law of exponents from our book. If we were to expand it and cancel it out, 2 to the 7th means in my numerator, there would be 7 2s. That's a lot of 2s. 4, 5, 6. And what you can notice is that this ends up being very time consuming, which is the whole reason we have the property, is to save us some of this time. Now, hopefully we remember that if we have the same number in the numerator and the denominator, they cancel each other out. 2 divided by 2 is 1. It goes away. Same thing with this set of 2's, and this set of 2's, and this set of 2's. Well, what am I left with? I'm left with 2 to the 3rd power. 2 because it's my base, and to the 3rd power because there are 3 of them left. Now, our law of exponents says if I have the same base, my base is 2, that's the same. All I have to do is subtract the exponents. So 2 to the 7 minus 4. Oh my goodness, what's 7 minus 4? It's 3. Again, all this is a shortcut. Can I do option 1 every single time? Absolutely I can. It's just going to take me a lot of time for a problem like this. Do I really want to write out x 18 times up here and then 7 times down here and then cancel it out? No, that's a lot of time. It's a lot easier for me to just do, what's 18 minus 7? Oh my goodness, x to the 11. So looking at some practice problems with that, again, in our examples, it shows us that that's what's going on. We're really canceling out, and that's why the subtraction works. So I do not want you to do the number part. I want you to leave it in terms of exponents. The only time I want you to multiply it out is if they're all different. This is the answer I want. Why? Because I don't want you spending a whole bunch of time doing multiplication when what I really want you to be working on is the problem itself. So for example, in part D, our base is 5. What are we doing with it? Since it's division, we're going to subtract the exponents, 7 minus 4. And it's always the exponent of the numerator minus the exponent of the denominator. That gives us 5 to the 3rd. That's the answer. I don't need you to give me 125. It's too much work. Here, our base is x. It's 10 minus 3. That gives us